Welcome to the second episode of the Space Infrastructure Hub podcast series. I'm Daphne Molewa from SASTA, the South African Agency for Science and Technology Advancement, a business unit of the National Research Foundation. Today I'm joined by Thomas Lesiba Tsoeleng, a remote sensing scientist from SANSA, the South African National Space Agency. Welcome, Lesiba.
Okay, well, thank you for welcoming me and inviting me to this session.
Yeah. Lesiba will one day be picking a theme on water resource management. Lesiba, just tell us a bit about yourself and the work that you do at SANSA.
Okay, thank you. Basically, the work that I do at the South African National Space Agency is focusing on water resource management. We look at how we use satellites in terms of assisting us in terms of monitoring our water resources. But in terms of career, I think during the early days in my career, I think I attended the National Science Week, which the theme then was Tomorrow's Science and Technologies in Our Youth Hands. And I happened to partake with a group from the high school, Tata Senior Secondary, where I was attending. And then there they were just displaying robotics and stuff like that. And then since then, I sort of got interested in the STEM fields. And then from then, I wanted to follow the STEM fields. I did mathematics and physics at high school and then went to university, studied environmental sciences. And then from there, University of Limpopo, moved to UKZN, went to KwaZulu-Natal to further my studies and do a master's degree. But before then, I got enrolled at the Space Agency after I did my honors. And then from there, I got a bursary through the SANSA bursary program. And then that is when I further my studies to do a master's degree in remote sensing.
Then Lesiba, tell me a bit more then, what sparked your interest in remote sensing?
I wouldn't say that it was a long-term goal. It is something that I found after I started studying environmental science. So that, within this field, there is remote sensing, there is environmental health, environmental management. You find that it's a broader scale of fields within environmental sciences. And then likely I got an opportunity at the South African National Space Agency, which then within the Space Agency, that is where you focus on geospatial technology in terms of the application. And then that is how I started to become a remote sensing scientist.
All right. You're touching a bit on geospatial technology. What is this geospatial technology?
Geospatial technology talks about the range of modern tools that we use to geographically map the Earth and human societies. Basically, it encompasses two key components there, which is what we call geographical information system, as well as Earth observation and remote sensing. Within geographical information system, you might be aware that grade 12 students who are doing geography, they are usually studying a geographical information system, which talks about the Earth. Geo, meaning that it talks about the Earth, and graphy is when you are writing on the Earth. So we are trying to write the Earth on a piece of paper. That is the history of it. You started from when they were drawing maps on stones, trying to represent the Earth on stones, and then it moved to papers. And then now it evolved to digital technology where you could represent the Earth on a computer. So geographical information system, meaning that it's a system that is giving you information about the Earth. And then within Earth observation, now within geographical information system, I spoke about the fact that it is representing the Earth, and then there are softwares which were built for us to be able to visualize the Earth. And then within that, we have Earth observation. Within Earth observation, we have remote sensing, which talks about the use of satellites to capture information about the Earth, meaning that you capture information without actually being in contact with that particular feature. It's like when you're taking a picture from a phone. Thank you.
All right. Well, this way you're mentioning a whole lot of components here. But first, before we even get into Earth observation and how it assists us in water management, what is water and why is it so important?
So water is important in many ways. I'll get into that, but we know that water is a liquid which is encompassing also actually I think about the literature saying that about 71% of the earth is covered with water, and then only about 97%, I mean, of which that 71%, 97% of that is available as salt water, which is not available for human consumption. Only about plus or minus 3% is available for human consumption. And then we know that water exists in as a liquid, it can exist as a solid, it can also exist as a gas. The solid state of water, it is like when you are freezing your ice cubes in a fridge. That is a solid form of water, but it's available on Earth. It is available in the glaciers, your ice in the oceans, and so forth. And then, as a gas, when you are boiling water, it releases a certain steam. That steam is gas, and then it can be available as a liquid, which is what we usually consume on a daily basis when you're taking a shower in the morning. That is water in a liquid form. And then it's available in many forms. You can find water in our rivers, in our dams, in our oceans, in our seas, and so forth. That is where you usually find water. And then the whole system usually talks about what we call the water cycle, the hydrological cycle, which talks about the movement of water on Earth from rain until when there is surface runoff.
So, Lesiba, what is Earth observation and why is it such an important tool?
So basically, Earth observation is the way we monitor the Earth using satellite in the outer space. So we use the tool to look at the Earth's biophysical and chemical properties, and as well as physical objects like your houses, your water bodies, your chemicals in the atmosphere, and so forth. So it is important in water because it assists us to look at water in a sort of like a bird's eye view. Instead of actually focusing on that particular feature, you can look at it at a larger perspective. So it gives you that broader perspective, and then also it assists us in terms of enhancing our visibility, in terms of looking at what is happening within our water resources, like the pollutants in the water. We are able to detect pollutants. We are able to detect many features using remote sensing, and also it assists us in terms of knowing the total number of water bodies we have, for an example, in the country, in terms of we have so many number of dams, and then we can also as well assess in terms of which dams are getting drier, and also looking at those patterns. Then when you come to factor in time series analysis, which is change detection, meaning you are taking the same area over time. You come back next year, take the same photo over the same area, come back the other year, take the same photo, the same area. So in that instance, sort of like you start to analyze patterns and trends. So you start to looking at things like, okay, there is water. Now you can see water. You're no longer asking a question about where is water. You know where it is water, but now you're looking at the changing aspect. You ask yourself, why is it changing? Why certain dams are getting drier? So you now start to give you that sort of like a mindset of focusing in terms of how then, why is it changing? What could be the effect of it to change? And then how, as we as humans, how could we actually assist in terms of, let's say, water, a certain dam is getting drier and drier, or let's say there are pollutants in a certain dams, you are able to detect that from a remote sensing perspective. And then from then you start to come up with mitigation strategies in terms of how could we sort of like mitigate pollution in those waters. Or let's say decision makers could look into how can we actually manage water, looking at it using an imagery instead of actually going to the field, spending too much resources trying to understand. Let's say in South Africa, we are monitoring about 280,000 dams. Imagine if you were to take a bucket to try and go around those specific dams to monitor water resources. It will be a tedious exercise. So with remote sensing, then you are able to get that picture at a one go, meaning that on a monthly basis, you can look at water nationally, And then from there, you can look at waters which are highly polluted, which there is more pollution in those particular water sources. And then from there, you can start focusing on those. And then there's no need for you to go to those ones which you have already identified that based on your Earth observation technology, it's saying to you that actually those dams are not polluted. You see that then you also focus your resources accordingly. Thank you.
And Lesiba, are those tools that you are mentioning for water management, are they available to the public?
Yes, at SANSA we have various tools that we've built as well as with together with industry in terms of monitoring water. We have what we call the Mzansi Amanzi system. That system gives you information about water extent as well as the volume estimate for those specific dams. Meaning that if you go online and type Mzansi Amanzi now, it will give you that picture where you can go and look at specific dam. Let's say that I'm interested in looking at Loskop Dam or Donald Dry Dam in my hometown. You could just go to the system and type Donald Dry Dam, and then it gives you the dam information. It tells you the volume, whether the water is available in that particular dam or not.
This is quite interesting, Lesiba. I mean, I'm hoping that the public will be able to engage with you on that app and, be able to look for themselves, how far the dams are. And, will that then be assisting us in knowing when there is drought, and are those apps able to do that?
So to a certain extent, you can also, I spoke about trends, that now you could look at trends. For an example, during the day zero season in Cape Town, if you were to look at that picture using the dashboard that we have, the Mzansi Amanzi, you'll be able to look at the dam as in when the size, the extent of that dam was decreasing, which was sort of like an indicator that there might be a possibility of drought. Because drought is a long-term phenomena that with our eyes, we cannot actually tell that actually drought is happening. You find that you only realize the impact that, okay, it seems like rain is no longer raining as normal, we don't have water. But we're using the tool, you can also look at the dams. They will tell you information that, okay, this area, it seems like there is shortage of water. Meaning that also it can also tell you that in terms of the agricultural managers and so forth, the farmers and so forth, they can, looking into that, they can start looking at the fact that, okay, maybe we have shortage of water, and start coming up with better strategies in terms of how do they work around those kind of conditions.
All right. Then Lesiba, tell me, what's next in the field? It seems like you guys have done it all. Is there still space to go further?
There are many applications which are still there, which I think students and learners could also partake in this field because of now, due to advancement in terms of technology. If you could look at over the years, since when, I don't know since when, but since it starts around, I think 1972, that is when we started taking a picture. What we'd do, would analyze it. We find that it would take a few days to get that picture. And then over the years now, there was advancement in terms of sharing of data. There's cloud computing. You find that instead of waiting for a hard drive to land in your office, you can download the data from cloud computing platforms. And then from there, you are able to analyze the data at the fly. And then now they are also merging what we call AI into the technology that we are using, meaning that you are no longer just analyzing data, that you can also factor in artificial intelligence to help you to analyze the patterns. Because of now, there are more satellite producers at a global scale, meaning that there is more data set to analyze. So in the future, you can see that there is always a changing. So for somebody who is interested in this field, it means that we have to be in a position to always acquire skills which are suitable for that time. For an example, you find that you studied remote sensing and GIS, you didn't study, let's say, machine learning models and so forth. You might find that you need to equip yourself with those skills. So for somebody out there, if you want to join the field, you study environmental science, and then from there, within various universities in South Africa, you can join the remote sensing field, and then you can join the space agency. And the space agency also offers those opportunities. Let's say you have an idea, but you are not yet at a university, or you want to start a company, and you are thinking that I could use geospatial technology to assist the public. Just like the Uber, your e-hailing system, they're using satellites to assist humanity in terms of transportation. So you find that there's somebody out there who has an idea. I think SANSA every year is issuing out a call which is called New Frontiers for students, learners, companies to partake in that program in terms of coming up with innovative solutions, brilliant ideas in terms of how we could actually help humanity using remote sensing.
All right. So what can we, as the public, do to assist you in water management?
Basically, I think what we are facing within the water resource fraternity, I think we are seeing pollution in most of our rivers, be it littering, be it throwing a plastic on the street. I think those are some of the simple things that we think that is simple. Maybe somebody will come and pick it up. But you find that over the years, they found themselves in a stream and then get deposited into a nearby water sources. And also, we know that South Africa is a water scarce country, meaning that if you're opening a tap or there is leak in your home, you find that water is wasted there. Already I've spoken about this earlier, that only a few percentage of water is available, and you realize that of that few percent that is available, most of those dams are being polluted. You can imagine that. So a simple thing that users at home could do is just to practice environmental cleanness, meaning that stop littering. When water is leaking, try to fix the leak as early as possible to save water, because we know that in the country there's water challenge in terms of scarcity in certain regions because of climate variability, of issues such as drought. And then also, you know that we have flash floods which are frequently occurring, which in a way you find that they deposit their sediments within our water sources, relating to pollution of most of the dams. So as a public, and as well as the farmers and so, because to a certain extent you find that the farmers, they use fertilizers in their farms, and then those fertilizers, they get deposited into nearby dams, causing pollution, invasive alien species like your cyanobacteria, which is highly prevalent in most of the dams in South Africa. So you find that as well as that, you need the public to take precautions, especially, let's say, those who are using boats. One of the things that we identified when we were doing field work in Loskop Dam, we realized that you find that a person is using a boat where there's water hyacinths. And then you find that after using that boat, they will take that boat to another dam, which is now transporting that particular invasive alien species into another dam and start mushrooming in that dam. So also the public, I think, could take precautions in terms of trying to alleviate those issues.
Thank you, Lesiba. That was very insightful. Thank you for sharing your water resource management knowledge with us. And to our viewers, thank you for tuning in.